Hello guys, welcome to my channel again. So this is the third series of the ongoing series on Java developer interview questions. So in this video we are going to talk about exception handling, and there were two videos before, so if you haven't take a look at these two videos. So first is your multi-threading and concurrencies, second is your memory management. Now in this video we are going to talk about exception handling. Now before we do that, if you haven't subscribed to my channel yet, please do. It doesn't take more than a second to subscribe to my channel. I see that a lot of you are watching my videos but not subscribing, which is really demotivating. So please subscribe, because this is going to help me in the long run, and that is how I'm motivated to make more videos like this. So yeah, let's kickstart this video. Alright, so now let's talk about exception handling. So the very first question, what is the difference between checked and unchecked exception? When should you use which? So by definition, checked exceptions are checked at compile time. So these exceptions are subclasses of exception, excluding runtime exception and its subclasses. So if a method can throw a checked exception, it must either handle it using a try catch block or declare it using the throws keyword in its method signature. And some of the examples are your IO exception, SQL exception, and let's say file not found exception. Now talking about unchecked exception, these are not checked at compile time. These are subclasses of runtime exception, which means that these are checked at runtime. So these include exceptions that generally indicate programming bugs. So we are not required to handle or declare unchecked exception. The compiler does not force you to do so. So the examples could be your null pointer exception, array index out of bound exception, arithmetic exception, right? So in general, checked exceptions are used when a method can encounter predictable but recoverable issues, whereas unchecked exception typically represent bugs that should be fixed by the developer. Now the next question, explain the importance of try with resources. How does it work internally? So this was a very big feature introduced in Java 7, and this means that when you have to close the resources in the finally block, don't do it, rather handle it in the try instead. So let's say if you have the buffer reader open, then just open the new instance of that buffer reader inside the try, and you don't need to close it now in the finally, right? So that was your try with resources. So the benefits that it is giving you is automatic closing, which means ensures resources are always closed even if an exception occurs, and that is what finally does it for you. Now we have code simplification, which means that it will eliminate the need for explicit finally block to close resources, leading to cleaner and more maintainable code. Now multiple resources, it support multiple resources, ensuring each is closed in the proper order, right? Now how does it work internally? So the try with resources work using auto-generated classes and lambda expressions. So when the compiler compiles the try with resources statement, it generates an instance of a special class called closable resource or auto closable resource. So this class ensures that the close method is called automatically after the try block is exited. Now let's move on to the next one. What happens if an exception is thrown in a finally block? So good thing is that it overrides any exception that was thrown in the try block or any previous catch block. So the exception thrown in the finally block becomes the one that is propagated, and the original exception is lost unless it was saved and rethrown. So we have to always be cautious about throwing exceptions in the finally block, because it can hide the original exception and make debugging more difficult. So it is generally more better to handle exception properly in the finally block to avoid throwing new ones. So handle exceptions rather than throwing them. So the best practice is to avoid throwing exception from the finally block unless absolutely necessary.
as it can cause confusion and make exception handling less predictable. So if you do throw exception in finally, ensure you log them or take appropriate action to track both exceptions, the one from the finally block and the original exception. Now the next question, is it ever appropriate to catch error or out of memory error? Why or why not? So this is a very tricky question. So my answer is no, because this means that, so whenever you get these kind of errors, this means that you have some serious issues in your application. So if you want to, if you let's say catch them, then it can lead to unpredictable behavior, and which is not actually going to help you out in any case, right? So so everyone knows that, so we know that error is a subclass of throwable that represents serious problem that typically cannot be handled by the application code. So similar to out of memory error, we have stack overflow error, we have virtual machine error, right? So we should not do it, and the reason I would say is that catching error can mask underlying problems that need to be addressed at a higher level, such as by restarting the JVM or handling the failure outside the application. So these are very fatal system errors and we should not attempt to handle. So I'm taking an example again. So if let's say we have out of memory error in our application, so this is often caused by insufficient memory or maybe memory leaks, so which is beyond the control of your application. So catching it does not resolve the underlying problem. So you need to figure out a way to fix this issue, maybe look at the heap dump or figure out what portion of the code is taking more memory or not releasing memory basically, right? So you need to figure out a lot of things. You cannot and you should not handle error, right? So yeah, that is that. Now moving on to the next question, how do exceptions impact transaction management in Java? Explain the role of transactional in handling exception in Spring. So I think this is going to be covered in the Spring Boot section as well, but because it is related to exceptions, so let's talk about it here. So transaction management is a big topic in your frameworks like Spring Boot. So when we talk about transaction, we can talk about asset properties. So we have atomicity, consistency, isolation, and durability. So these are some of the properties that we need to take care of whenever we talk about transactions, right? Now, impact of exception on transactions. So when an exception occurs during a transaction, it can have one of the following impact, like roll back the transaction, commit the transaction, transaction management decisions. So if an exception indicates a failure, the transaction should be rolled back to avoid committing incomplete or invalid changes. So that is rolling back. Now, if no exception occurs, the transaction is considered successful and the changes and the changes can be committed, right? Now the decision to commit or roll back depends on the exception type. So either it could be checked or unchecked, and the transaction settings. Now talking about transactional annotation, so we have two types of transaction management in Spring. We have programmatic and declarative transaction management. So the declarative transaction management is your transactional annotation. So by default, Spring's transaction management will roll back on unchecked exception, like your runtime exception, and commit for checked exceptions, right? Now if you take a look at this example, so if a runtime exception is thrown, the transaction will be rolled back immediately. If a checked exception is thrown, Spring will commit by default unless the transactional annotation is configured to roll back on checked exception. Now you can customize this rollback behavior. You can use rollback for and no rollback for attributes. So rollback for is to specify which exception should trigger a rollback, and no rollback for to specify which exceptions should not trigger a rollback. So here you can see the example. So here the transaction will roll back if SQL exception is thrown, and the transaction will not roll back if illegal argument exception is thrown. Now moving on to the next question, how do you handle uncaught exceptions in thread? Explain the role of thread dot uncaught exception handler. So the second question is the answer to your first question, but let's talk about it. So when an uncaught exception is thrown in a thread, the exception will cause the thread to terminate, or the exception will not propagate to other threads. So if not caught within the thread, the exception is logged to the console, but the program continues running for other threads. So this is the default behavior. Now, talking about uncaught exception handlers, so Java provides this interface which allows you to define a custom handler for uncaught exception in any thread. So this handler is invoked when a thread terminates due to uncaught exception. So here if you see, so we have this example, and here we have defined a global uncaught exception handler using thread.setDefault uncaught exception handler. So when an uncaught exception is thrown in the thread, the handler prints the stack trace. You can customize the handler to log exception or perform other actions like alerting, saving state, or notifying users. Now moving on to the next question, how does Spring handle exceptions in controller? Explain the use of controller advice and exception handler. So by default, when an exception is thrown in a Spring controller method, it will cause the request processing to stop, and the exception will be passed to the appropriate exception resolver if it is there. The default behavior in Spring is to return a generic error response such as a 500 internal server error, which I think you might have seen already, with the stack trace in the response body. Now this is not ideal, so how do we actually handle it in a production or a real world application? So either we can handle exceptions with exception handler, or we can use global exception handling with controller advice. So let's talk about that. So Spring provides a convenient way to handle exceptions within a controller using the exception handler annotation. So this allows you to define methods within your controllers that handle specific exception. Now, keep that in mind. This is very specific for a particular controller and not open to all sort of controllers, right? So this is not generic. Now here in the example, you can see that we have a method handle custom exception, where if we get the custom exception, in that case this is going to get triggered and respond back with bad request, which is your 400, right? Now another option is global exception handling. So to handle exceptions globally across multiple controllers, you can use controller advice annotation. This allows you to centralize exception handling logic in one class, avoiding repetitive code across multiple controllers. So if you take a look at this example, we have two types of exception. One is custom exception, another is exception, and this is a single class, and this is going to be open for all the controllers. So any controller, if they are getting these two types of exception, then they will see this kind of response, which is your bad request, and the second one is internal server error. Now the next question, what happens if multiple exceptions are thrown in a try with resources block? Which one is propagated? So this is a very tricky question again. So there are two kind of scenarios. Exception is from the try block and exceptions from resource closing. So if an exception occurs in the try block, it will be thrown and propagated as usual. Now if any of the resources throw exception when they are closed in the finally block, these exception will not be captured. Now which exception is propagated? So exception that occurs in the try block is the primary exception, and it is the one that is propagated to the caller. If an exception occurs during the closing of the resources, it will be suppressed and added to the list of suppressed exception of the primary exception. Now how are these suppressed exception managed? So the suppressed exception are available in the get suppressed method of the primary exception. These suppressed exceptions do not prevent the primary exception from being propagated. They are simply recorded for informational purposes. So if you take a look at this example, here the output is going to be your main exception in try block, and then we have two separate suppressed exception in resource 1 and exception in resource 2. So how this happened, like I said before, the first exception is going to be your try block one and then your suppressed one. So how we are getting these suppressed one? We are actually iterating over the suppressed messages and iterating over them and printing them one by one, right? So not a very complex code, but this gets you the idea. Alright, now the last question: what does the throw keyword without any arguments inside a catch block do? So this is basically to read through the exception that was caught in the catch block. The exception is rethrown as it is without any modification or additional context. Alright, so we are now done with exception handling.
Alright, so this was it for this video. In the next one, we are going to talk about collections and generics. So stay tuned for that. And if you still haven't yet subscribed, please do that. And I will meet you in the next video. Till then, keep learning, stay happy. Bye-bye.